Hey everyone! In this video we're going to walk through question 9. This is on your chapters 10 and 11 worksheet on hypothesis testing. So let's go ahead and dive right in. So most air travelers now use e-tickets. Electronic ticketing allows passengers to not worry about paper tickets, and it costs the airline companies less to handle than paper ticketing. However, in recent times the airlines have received complaints from passengers regarding their e-tickets, particularly when connecting flights and a change of airlines were involved. To investigate the problem, an independent watchdog agency contacted a random sample of 20 airports and collected information on the number of complaints the airport had with e-tickets for the month of March. The information is reported below, or in our case to the side. At the 0.05 significance level, can the watchdog agency conclude the mean number of complaints per airport is less than 15 per month? So in this question, unlike some of our others, we have the raw data. So we don't have summary data, we have the raw data of the actual number of complaints. And so because of that, we need to figure out some of our variables. So one of the things we're going to need to figure out is, we'll start with what we know. So we know N, we have 20 airports. We also know, and put this at the top, we also know what alpha is, right? This is our level of significance, is 0.05. To do this hypothesis test, we're going to need to know a couple of things. So we're going to need to know the population mean, and we're going to need to know the sample mean, and we're going to need to know the sample standard deviation. Now the population mean, even though it's not given like fully at the top of the question or that they assume anything to be true, the question itself down here, which we should underline like we usually do, is can the watchdog agency conclude the mean number of complaints per airport is less than 15 per month? So the number we're comparing to is 15, and so that is going to be our population mean. Now we need to solve for our sample mean and our sample standard deviation, and we can do that based on the raw data that we have. So to find the mean, we can just take the average of our data, and then we can find our standard deviation, like so. Okay, STDEV does give us the sample standard deviation. If you needed a population standard deviation, it'd be STDEV.P. Okay, so from this information, we can see that we have a sample mean of 13.5, which is in fact less than 15, so our question seems to be valid. Now we can go ahead and write out our null and alternate hypothesis statements. So we have our null and our alternate, and specifically the variable that we're looking at, once again, is the mean. We're doing a mean versus a number because we just have one sample that we're comparing to 15. So our question, we're going to start in the alternate, is that is the mean less than 15, which means the null is the mean greater than or equal to 15. So this is how we should set up our null and alternate hypothesis statements. Now that we have that, we need to go ahead and figure out what our critical value is. So we're going to go ahead and draw our curve. Now this is a one-tailed test because we do have inequalities. We only have a two-tailed test if we have an equal sign. That's if the question was, is there a difference? In this case, we want to know, is it less than 15? Now 15 goes in the middle right here. And we are going to be on the left side of the curve, on the negative side, because the question is it less than 15? And so now we need to figure out what is the critical value at the beginning of that shaded area. Now before we do that, we need to figure out what our distribution is. Are we going to be using Z's or are we going to be using T's? The main question you ask is, do I know population standard deviation? And in this case, we don't. We also have a small n of 20, so we're going to go ahead and use the t distribution. So we need to find the critical value for the t distribution with an alpha of 0.05 for a one-tailed test. So over here, I'm going to put critical t, and let's go ahead and solve for that. I'm going to use my f of x button and search for my t distribution. Okay, so here's t.inv.2t. That 2t stands for two-tailed, which is not what I want because I only have a one-tailed test, which means all of 0.05 is going to sit in that one tail. The t.inv would be a left-tailed test, which is exactly what we're looking for. You could also use that if you were doing a right tail. You would just make your number positive instead of negative. Okay, so t.inv, we need to know two things. We need to know the probability, which we have. That was 0.05. And then our degrees of freedom. Now, if you remember, degrees of freedom is n minus 1, which makes our degrees of freedom 19, because we had a sample size over here of 20. So we end up with a critical value of negative 1.729. So we have negative 1.729. Sorry, my writing is terrible. Okay, so we have our critical value. So therefore, if we now get a t-value, solving using all of our numbers, if we get a t-value that's less than negative 1.729 in the shaded region, then we would reject the null. The equation we're going to use, let me write it over here off to the side, is t equals our sample mean minus our population mean over sample standard deviation over the square root of n. It's almost identical to the z equation, except that we substitute sigma for s because we're dealing with the sample instead of the population. Okay, so now that we have a critical value, we're going to get our test statistic t-value, and we can go ahead and solve. So our numerator is the sample mean minus the population mean. That should give us a negative value, 13 minus 15, divided by sample standard deviation, divided by the square root of n. Okay, and once we get that, we get a negative 4.45. So that number right there is really, really tiny compared to our other one. It's going to be very far into the tail. Therefore, our decision, let me switch to something else, would be to reject the null hypothesis because we're in the shaded region, we're really far in the tail, and accept the null, which is that the mean is less than 15. So when your decision is that you reject the null, when you interpret that, you need to go back and answer the question, which is that the mean number of complaints is in fact less than 15 per month.